Hi guys, welcome back to Math with OG. In this video, we'll be looking at LCM, HCF and the relationship connecting them. That's the relationship connecting LCM and HCF. In our last video, we looked at factors and we looked at multiples. So I believe by now you already know the meaning of factors of a number and also you know the meaning of multiples of a number. Now, how do we solve LCM? Also, how do we solve HCF? We just follow the name. Now, the first question here, we have to find the LCM and the HCF of the numbers. A is simply 4 and 6. The LCM and the HCF of 4 and 6. Now, what is LCM? LCM, like it's boldly written here, is lowest common multiple. And HCF is highest common factor. That simply means for LCM, you look for all the multiples of the number, not all, some of the multiples, then pick out the ones that are common. Inside those that are common, the lowest common multiple is your LCM. So if we are solving for 4 and 6, we want to look for the LCM of 4 and 6. So I'll bring out the multiples of 4. Like we said, multiples of a number, you keep multiplying that number by whole numbers. So starting with 4 times 1, you have 4. Next, you have 8. You have 12. You have 16, 20, 24, 28, 32, and so on and so forth. Then for 8, you have 6. For 6, you have 6. You have 12. You have 18. You have 24. You have 30. You have 36. You have 40. You have 42. There's no 40 being a multiple of 6. Here you have 36 and you have 40. Now we've listed as the multiples. You are not supposed to extend it that long. Now what are the common multiples? You have 12. You have 24. You have 36. So you also have other common multiples, but these are the first three that you can see here. Now, in these common multiples, which of them is the lowest? The lowest is 12. So therefore, automatically, the LCM is equal to 12. So that's how you find LCM. However, this method is kind of strenuous because there are times where the numbers will be very huge and bringing out the multiples might be time consuming. So there's a shorter method for finding LCM where you put it in a tabular form, and start dividing till you get to a part where both numbers cannot be divided again. That means both numbers will become 1 and 1. So what do I mean? LCM of 4 and 6. I bring 4 and I bring 6. Then I start dividing. Divide by any number, be it a prime factor, be it not a prime factor, as long as that number you are picking can go into either this or this, you are good to go. As long as I can go into either this or this, you are good to go. So we start with 2. We start with 2. 2 into 4, you have 2 here. 2 into 6, you have 3. So I need to go back to what I said before. When dividing, it is advisable you use prime factors. But if you don't work with prime factors, chances are you are going to get a wrong answer. So always divide through by prime factors. Now next, you use 2 again. 2 into 2 is 1. 2 cannot go into 3. So we don't bother dividing it. So we just drop this 3 the way it is here. Then we go again. 3 can go. This guy is automatically 1. So we have no business with this guy. Next, you have 3. 3 cannot go into 1. We'll leave it that way. 3 into 3 is 1. So the moment we're having 1 and 1, that's the end. So how do I get the LCM? Simply multiply these numbers here, which is 2 multiplied by 2 multiplied by 3. And this should give us 12. And that was the answer we got earlier on. Now on to the next question. We have 2, 6, and 8. 2, 6, and 8. So this will be the last time I'll be using this method to find LCM, because I can't, or I won't obviously use this method for this. Can't start solving 18 times 2, 36 times 2, as the case may be. It will take our time. So let's look for LCM of 2, 6, and 8. So starting with 2, the multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Multiples of 6, you have 6, 12, 18, 24, 30, 36, 42, 48. Multiples of 8, you have 8, 16, 24, you have 32, you have 40. Let's stop there. So far, so good. We've not gotten a common factor. See why this method is quite strenuous. It takes time rather. So you can see here 2 is not common, 6 is common to these two, but it's not here. What else you have? 12 is common to these two, it's not here. 8 is common to these two, it's not here. You have 16 here, 16 here, 16 is not here. You have 18, 18, no 18 here. But it's obvious that since I'm having a 24 and a 24, if I continue with the factors of 2, I'll get a 24. I think I have to wipe this. I have to wipe this part. So here you have a 22 and a 24. So automatically the lowest common multiple is this guy, 24, 24, 24. Any other multiple we are going to get are not the lowest common multiple. And once you've gotten the lowest common multiple, to get the next common multiple, multiply by 2. Next common multiple, multiply by 3. If I ask you what is the fourth common multiple of this of 4 and 6, the answer is 12 multiplied by 4. What is the 10th common multiple of 4 and 6? The 10th common multiple is the lowest common multiple multiplied by 10. The first common multiple is simply the lowest common multiple. So what will be the second common multiple of 2, 4, and 8 is simply 24 multiplied by 2. That is 48. The third common multiple will be 24 multiplied by 3. Whatever value you get will be the answer. The 10th common multiple is 24 multiplied by 10, which is 240. Now we've gotten this. Let's use the tabular method to find the LCM of 2, 6, and 8. So tabular method, you have 2, you have 6, and you have 8. Remember, divide by prime factors. Divide by prime factors. There are cases where you don't necessarily have to divide by prime factors, but it will be quite confusing. As you solve more questions, you will get used to it and you will understand how to solve without dividing by prime factors. So let's divide 2 by prime factors. So we'll start with 2. 2 into 2, 1. 2 into 6 is 3. 2 into 8 is 4. We go again with 2. 2 into 1. 2 into 3. 2 into 4 is 2. We go again with 2. 2 into 1. 2 into 3. 2 into 2. Lastly, we go with 3. 3, 1, 1, 1. So my final answer will be 2 times 2 times 2 times 3. This is 8 times 3, and that is 24. As easy as that. So that's the lowest common multiple. Then the last one, 36, 18, and 40. Like I said, for this guy, we will not be using the elongated method. We'll just use the tabular method straight. So let's solve it here. 36, 18, and 40. So let's go. Starting with 2, this will give us 18, this will give us 9, this will give us 20. Go again with 2, this will give us 9, this remains 9, and this will give us 10. We go again with 2, this is 9, this is 9, and this is 5. We go with 3, 3, 3, 5. We go with 3, 1, 1, 5, and we'll go with 5, 1, 1, 1. So my LCM here is simply 2 times 2 times 2 times 3 times 3 times 5. Now, easiest way to get the answer, let's first multiply 2 by 5, because I know that it's easy to say 10 times any other number. I'm just teaching you the easiest way to go about it. But going 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. 24 times 3 might confuse some people, except you're using your calculator. Then that value times 5 will even confuse you the more. So how do you bypass this confusion? Just start with 2 times 5, 10. You've kept your answer. You know 2 times 2 is 4. You know 3 times 3 is 9. So you can easily do 4 times 9. 4 times 9 is 36. Now what is 36 times 10? It's simply what? 360. So it's faster that way. But going through this method, this is 4, this is 8, this is 24. 24 times 3, 2 carry 1, 6, 72. 72 times 5, 0 carry 1, 35, 36. You can see that you are still getting 360. But if you are writing an exam that you have to be time conscious, you should learn ways in which you can get your answer as fast as possible. So that's that for LCM. That's that for LCM. I believe it's clear. Now let's move on to HCF. What do we look for in HCF? We look for the highest common factor. Highest common factor. That means you list out all the factors and pick out the common factor that is the highest. You may have more than one common factors. The highest of all the common factors is the answer. So I can wipe this. Now you might be asking yourself, what is the essence of learning LCM and HCF? So they have a role to play in solving questions in mathematics. For example, I can give you a typical example. Whenever you are solving fraction, addition, subtraction, and fraction, remember, we usually look for the LCM of the denominator to make things easier. So that's one of important reason why you should know your LCM. Else you won't be able to solve your fractions effectively except you are with your calculator. Then for HCF, why do we need HCF? For factorization. When you have to factorize a number, you simply eliminate the highest common factor and leave whatever is not common inside the bracket. So I can just give you a typical example, though it's me digressing. So you have something like 4x plus 8y. What is the highest common factor here? Is 4. When you have to factorize, what you factor out is actually the highest common factor. So you simply say 4 into what? X plus 2y. So that's one of the importance of HCF. Now, how do we get this HCF? So starting with the very first question, 4 and 6. 4 and 6. So I'll bring out the factors of 4 and the factors of 6. 4. Factors are 1, 2, and 4. 6. Factors are 1, 2, 3, and 6. Now, what are the common factors? 1 is a common factor of all number. 1 is a common factor of all number. Another common factor is 2. So what is the highest common factor? The highest common factor is equal to 2. As easy as that. Now, if I don't want to go through this method, I want to use the tabular method. How do we solve? Bring out your 4 and bring out your 6. In this case, you divide by a number that is common to both of them. For LCM, you divide by a number that can go into any of them. If it's going into both of them, there's no problem. But for HCF, the number must go into both of them. So 1 can go into both of them, but there's no need putting 1 here because it will not change the number. So move on to 2. 2 can go into both of them. You have here to be 2, you have here to be 3. I believe there's no number that can go into both of them except 1. So you can't be putting 1, 1, 1, 1, 1. You are repeating yourself and it will not change anything. So the only factor that can, or the only number that can go into both of them apart from 1 is 2. So my HCF here automatically is equal to 2. Now the next question. You have 2, 6, and 8. 2, 6, and 8, the same HCF. 2. Factors of 2, 1 and 2. Factors of 6, 1, 2, 3, 6. Factors of 8, 1, 2, 4, and 8. What are the common factors? 1, and the other common factors? 2. Sorry, and the other common factor? 2. So automatically, HCF is equal to 2. Tabular method, you have 2, 6, 8. What number can go into the three of them? Number that can go into the three of them is 2. You have 1, you have 3, and you have 4. I believe there's no number that can go into 1, 3, and 4. So automatically, the HCF will be equal to 2. So that's the answer to that question. Lastly, we have 36, 18, and 40. 36, 18, and 40. So I won't want to use this method. Let's just go to the tabular method straight. But listing out the factors of these guys is not that complicated. But listing out the multiples is a bit complicated. Listing out the factor is not a big deal, but let's use the tabular method. So we have 36, we have 18, and we have 40. So smallest number that can go into three of them is 2. This will give us 18. This will give us 9. And this will give us 20. So can any other number go into a three of them? Adapt. 2 can go into this, cannot go into the 2. The other 2 can go into this and this cannot go into 9. 3 can go into this and this cannot go into 20. 5 can go into only this. So the ACF here is automatically equal to 2. Please, I have not said, there was no point in this video where I mentioned that the ACF is always 2. Coincidentally, we're having ACF to be 2 for the 3 cases. I think it's best I just formulate a question where the ACF is not 2. So let me just formulate a question where the ACF is not 2. For example, look for the ACF of 36 and 18. Look for the ACF of 36 and 18. So there's no 40 anymore. What will be the ACF? We'll start with 2. This is 18, this is 9. We go with 3, because 3 can go into both of them. This will give us 6, and this will give us 3. We'll go with 3 again. This will give us 2, and this will give us 1. So the ACF of 36 and 18 is simply 2 times 3 times 3, and that is 18. So it means I have indicated myself that 2 is not always the answer when you are looking for HCF. So that's how you find LCM, and that's how you find HCF. However, there's one last thing we need to talk about, which is the relationship between LCM and HCF of two numbers. The relationship between LCM and HCF of two numbers. I repeat, just two numbers. Now, what is the relationship? So let me wipe here off. Let's say we are dealing with two numbers, A, B. The LCM of A and B multiplied by the HCF of A and B is equal to the product of A and B. So take note. The LCM of A and B multiplied by the HCF of A and B is equal to the product of A and B. So let's use one of our examples to prove that our answer is correct. So when we looked for the LCM of 4 and 6, I believe our answer was 12. That was the LCM of 4 and 6. Then when we looked for the HCF of 4 and 6, I believe that our answer was 2. So the LCM of 4 and 6 multiplied by the HCF of 4 and 6 should give us the product of 4 and 6. And 12 times 2 is 24. 4 times 6 is simply 24. So that's that for that. Then before we continue this LCM and HCF, let me also mention one thing. There are cases where we have to find the HCF of two numbers and you'll be confused that there's no common factor. There's no common factor. Whenever you have that thought of there not being a common factor, just know that your answer is 1. For example, your teacher walks up to the class and asks you, what is the HCF of 2 and 3? You'll be like, no number can go into 2 and 3. The moment you start having that thought, just note that the HCF is 1, because 1 can go into 2 and 3. That's the highest common factor. If I bring out the factors of 2, I have 1 and 2. Bring out the factors of 3, I have 1 and 3. So this is the highest common factor. You can also see that in the HCF. Let's say you have to find the HCF of 5 and, let me pick a random number, 16. The HCF of 5 and 16. The answer should be what? 1. Because no other number can go into 5 and 16 apart from 1. So that's by the wayside. Now let's continue with this. LCM of two numbers multiplied by HCF of two numbers should be equal to the product of the two numbers. Now that we know that, let's answer the last two questions here and we'll round off this class. The product of two numbers is 120. If the HCF is 6, what is their LCM? If the HCF is 6, what is their LCM? Product of two numbers 120, LCM is 6. What is their, sorry, HCF is 6. What is their LCM? So their LCM I don't know. Their HCF is 6. The product of the two numbers is equal to 120. 6 here 1, 6 here 20. So x is equal to 20. I believe you all know what we did here. I divided both sides by 6. Equation, whatever I do to the left hand side, I should do to the right hand side. So this was giving us 6x to be equal to 120. I did over 6 over 6. 6 cancel 6. 6 here 1. 6 into 12 is 2. So x is what? 20, because 6 into 0 is 0. So that's that for the first question. Second question, we are told that the HCF of two numbers is 3 and their LCM is 54. If one of the numbers is 27, find the other number. HCF of two numbers is 3. So HCF is 3, LCM is 54. So in place of LCM, I can put a 54. In place of HCF, I can put a 3. One of the number is 27. The other number, I don't know. Let's call it x. 54 times 3 equals 27 times x. So in order not to multiply and confuse ourselves the more, I can simply just cancel out by saying 27 here 1, 27 into 54 is 2. So x is equal to 2 times 3 is what? 6. So what did I do? I divided both sides by 27. I can also do it this way. 3 here 1, 3 into 27, 9. 9 into 9, 1. 9 into 54, 6. So there are so many ways you play with numbers to get correct answer. So that's the answer to the question. So I believe you now understand HCF better, LCM better, and also the relationship between LCM and HCF of two numbers. So in our next video, we'll be looking at directed numbers. That's your negative number, your positive numbers. How do you add them up? How do you subtract them? How do you multiply them? And how do you divide them? So what I mean is that if you are given a question of minus 2 times minus 5, how do you solve it differently from minus 2 times plus 5? So we'll look at how negative numbers and positive numbers work in operations. So that's what we'll be looking at in our next video. Thanks for watching this video. Kindly hit the like button if you find this video helpful, and also hit the subscribe button. Don't forget to share with friends that you know will need this video, and also use the comment section if you have any questions or you have any observation you wish to point out. Thanks for watching once more, and see you guys in my next video.